All right. So today we're going to build more on our information that we got last class. Talking about more variables, talking more about data. So first things first, let's just do a brief review of the data types we talked about last class, and then I'm going to do a bit of a deeper dive into each one. We have our two numeric data types, int and double. We have our two textual data types, string and char, and we have our true or false data type, Boolean. So let's talk about ints. Int is short for integer, which we probably recognize from math classes. Int values are always going to be whole numbers. You cannot have a decimal place when you are working with an int. Int values can be positive, negative, or 0. So some potential examples would be 5, 0, or negative 100. All of those are valid integer values. Double type values, like int values, can be positive, negative, or 0. Unlike int values, you may use you may have values in the decimal places with a double value. So anytime you make a double value, it will always have a decimal point, even if there's not any actual information after it. So some potential double type values, 12.34, negative 135 point a bunch of different numbers, or even just 0.0. Even though there's nothing after my decimal place here, I still am going to be storing this as a double because it has that decimal place to begin with. So even if I have the number 5 and the number 5.0, I'm going to store those into different data types because one of them has a decimal place. That's the difference between float versus double. I think they're similar in Java. I think one of them has a higher capacity for like you can have bigger numbers. I don't recall which one has a larger capacity. CodeHS wants us to use double for decimal place values, but you could also use floats, I believe. Yeah. So CodeHS wants us to use doubles though. So if you're going to make a variable with a decimal place, CodeHS is probably going to be looking for a double. So for the auto reader's sake, I would use doubles. Good question though, thank you. A little bit more about strings. A string value refers to a sequence of 0 or more characters stored between double quotes. The characters that can be included in a string are any character that you can type in on your keyboard, whether they're alphabetical, numerical, or symbols. We talked about string literals on the first day we talked about programming. So you can reference that one again if you need a refresher about strings. Some examples of string type values. Hello with an exclamation point. Exclamation points are totally okay if they're inside of a string. 1, 2, 3, a valid string. Empty quotes, just open quote, close quote, is a valid string because as long as you have those double quotes, you've created a string value. It doesn't have to be any value in between the quotes for it to be a string. And this also counts as a string, even though it means nothing. There's just a bunch of characters here. All of those characters are valid to have within a string. So that is a valid string value as well. About the char data type, or char, however you want to say it. It's short for character. So the char data type is used to store single character values. Similarly to a string, the char, I can't just mix them up. A character variable can include any character that is typable on a keyboard. A character value needs to use single quotes instead of double quotes. So strings use double quotes, characters use single quotes in Java. The distinction is important. So some valid character type values. Oh, the letter A, the character 5, capital M, the greater than symbol. These are all valid character values. Invalid character values would look like this. Having double quotes is not a valid character, and you cannot have more than one character inside of your single quotes, otherwise your Java will throw an error. So you can have a string that is one character long, but you can tell the difference between a string and a character by the type of quotes around it. If you have single quotes, it's a character. If you have double quotes, it's a string. Does the difference between string and character make sense? I'm going to go more in depth later today about some more fundamental differences. Okay. And then our last common data type is Boolean. There are only two values that a Boolean variable can hold, true and false. If this variable type does not seem very useful to you right now, that's okay. We will discuss a place in programming where Boolean values will be much more useful. So if it doesn't make sense why you'd use this right now, that's okay. All right. Different data types use operators, so plus, minus, multiplying, etc. So different types use these same operators in different ways. So in this example, I'm going to be using the plus sign operator. If I use a plus sign with numbers, so let's say I have two variables, 1 and 2, both of them are storing an integer. 1 stores the number 1, 2 stores the number 2. If I make a variable 3 equal the value stored in 1 plus the value stored in 2, so that's going to be the number 1 plus the number 2, what is 3 going to equal? I believe in you guys. What is 3 going to equal?
3.
3, absolutely correct. Well done. So when I print out my value stored in that variable, I will see the number 3. Because when I use the plus sign with numbers, it does addition just like you would expect. However, if I use the plus sign with strings, let's say I have a string named 1, storing the word 1, and I have a string named 2, storing the word 2, and I make a string named 3, equaling 1 plus 2, the plus sign with strings in Java is going to do a process called concatenation. And that is when you stick a string directly on the end of another string. So the value stored in 3 is going to be 1, 2. It's going to be one long string storing all 6 of those characters. So just say 1, 2. That is the contents of my variable 3. And we'll talk more about different operators for different variable or different value types at a later point in time. But for right now, it's just important to know that different data types can use the same operators in different ways. All right, so we're going to get a little bit more nitty-gritty. Even within these 5 simple data types, int, double, char, string, bool, there are 2 major types of data type. There are primitive and reference data types. Primitive data types are the essential building blocks of any programming language, and they store data very simply. Reference data types are built by programmers using primitive types as building blocks, like it says here, and they generally have more functionality. Here is a lovely table, which I lifted directly from CodeHS. A lot of what's in here is not going to make much of any sense yet. Later throughout this class, all of this table will make more sense. For right now, let's look at the bottom row. In our primitive column, some examples would be our character, int, double, and Boolean data types. And the one reference data type we've learned so far is string. Can anyone see any differences between the names of these different data types?
It's capitalized.
Exactly. String has a capital S where none of these are capitalized. So that is important because remember, Java is case sensitive. So the capital S in string is going to tell us that we're using that specific data type. And any time we have a reference type of data type, I'm saying word type a lot, it's going to have a capital letter at the beginning. And we'll learn what that means and why later. But for now, it's important to know primitive variables are going to store primitive values, and reference variables store the address of the value. I'm going to show you an illustration of what this looks like so that that makes any amount of sense. When I create a variable with a primitive data type, the computer is going to store that value in binary, because that is how computers store all information, is in binary. And if you're unfamiliar with how binary works, we will go over that at a later point in time. But for now, we're just going to show you what it kind of looks like in the computer. So if I have a line of code saying my character X equals the letter A, in my head, I'm thinking X is just storing the letter A, capital A. But in the computer, it will store it as 010000001. Did I say too many zeros? I don't know. But this is how the computer will store that information. It stores it in binary. So important to keep that in mind as we go forward. When I make a variable with a primitive data type, the variable will be associated directly with the value that I assign it. When I overwrite one of those variables, the primitive value that is being stored is going to be changed. So if I have two variables, I have first and second. Both of them are characters. First is the letter A, second is the letter B. And then I have a line of code saying first equals second. The value in first's box is going to change to whatever was in second's box. First gets B, second gets B. Second is unaffected by this change. Does how this generally works make sense? All right, it gets a little more complicated with the other one. So with reference typed values, when I make a variable of a reference data type, the variable is going to be associated with the memory address where the data is stored. So when I make a change, it looks more like this. Instead of saying my variable string1 equals the string of the word 1, I'm saying my string1 is looking at this box. My string1 is pointing towards this box that stores the word 1 in it. The information stored in that variable is just remembering where in my computer's memory is this information stored. And same with my string2, storing the value 2. So if I say string1 equals string2, then the value stored in string1 is going to be equal to the value in string2. And that is going to be the memory address for what string2 is holding. So from a user perspective, this is going to look very similar to this. If I were to print out the contents of each of those variables, first and second, and then string 1 and string 2, it would look identical. We would see B and B, we would see 2 and 2. But once I've done this, string 1 and string 2 are both looking at this same box. They're both looking at that same address in my computer's memory. So if I change the contents of this box, then both string 1 and string 2 will be affected because they're both looking at that box. In addition to that, this box storing 1 is still going to hold that data. It's not going to get lost, unlike in this previous one where that A disappeared. The reference to that box is gone, so I can't go back and say my string 1 equals that box again. I can't tell it to look back and find that memory address, but that memory address, that value, still exists in my computer. So somewhere down the line, there's going to be an automatic process in Java called garbage collection, and it will free up any memory that doesn't have a reference to it. So it'll wipe out that box, letting that space be used for some other program. And that's all you need to know about garbage collection, is that it frees up inactive memory. You don't need to know anything else about how it works for this class. You just need to know that it exists. Does that difference between primitive and reference variables make sense? Yes? All right, cool. I'm going to stop the recording after I stop sharing.